Hello, this is lesson 3 from Unit 3, Solving Quadratic Equations for our MCF3MI math class. We're going to continue to build on different ways to solve quadratic equations. Today we're going to be looking at the quadratic formula. So just to get us up to date from where we were, part A and B are recalls for what we've done the last 2 days, which is first, solving by rearranging and taking square roots. We do this when our quadratic equation is in vertex form or when it's in standard form without a bx term. Basically, if you have your x in one location in your quadratic equation, then you can perform BEDMAS backwards to isolate your variable and determine what x is equal to. And again, we're looking for, if these were quadratic functions, we'd be looking for x-intercepts, but now that we're looking at quadratic equations, i.e. equations that are set equal to 0 and have only one variable, we're looking for, quote, solutions, which are really the same as x-intercepts. The second way, which we looked at in the last lesson, was solving by factoring. So if we're given a quadratic equation that has x's in multiple places, so things like simple or tricky trinomials, we're going to be solving by factoring. We factor, and then we set each of the components in the factor equal to 0 to solve for x and find out what the solutions are. But I guess the question becomes, and which is our starting point today, what if the quadratic that we have is not factorable? So there is a method that will work every time, and that is using the quadratic formula. So for those coming from grade 10 academic, this is review. You've seen this before. For those coming from grade 10 applied, think of the quadratic formula as a way of arriving at x-intercepts, or in this case solutions, for quadratic equations. The quadratic formula, and I'm just skipping over the actual bulk of the words in this lesson. Really, part C talks about solving by graphing or technology. Now, graphing we did in Unit 2, and technology we'll be looking at more in other units, although it's hard to say if we'll even have time to sort of look at the technology this semester, this year. And we're going to scooch right over to number 4, which is solving using the quadratic formula. So here's our quadratic formula. It is actually a rearranged version of the standard form version of a quadratic equation, ax squared plus bx plus c, set to isolate x. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that sounds complicated. It's something that you should endeavor to memorize, but it's not really the end of the world if you need to reference it every time that you're working through solving a quadratic equation that is not factorable. So let's look at our first example. I've just left it in our note complete, and I'll just sort of talk our way through it. Let me zoom in just a little bit here. Okay, so what we've got is a quadratic equation in standard form. We have x squared plus 3x minus 2. Now what I want to point out is this x squared plus 3x minus 2. The order of the terms doesn't matter. The a term is always going to be the coefficient in front of the quadratic or squared term. In this case, a will equal 1. The b value will always be the linear term. In this case, 3. That will be the number out in front of the term that just has a single x as opposed to an x squared. And the c value is our constant. Now signs are important, so you'll notice that I've written negative 2 here for our c value. It's also important that all 3 values are on the same side of our equation, which means that the x squared, the x, and the constant term have to all be on either the left or the right in order for us to get the right answers by using the quadratic formula. So I'll zoom back out. I've rewritten the quadratic formula here, negative b plus minus the square root of b squared minus 4ac all over 2a. And I really want to also stress that the whole numerator has 2 parts, the negative b and then the plus minus square root bit. It's all over 2a. So when you're working through questions like this, you need to complete the numerator, find out what the value is in the numerator before you divide by 2a. Second step I did here is substitution, so I'm subbing in a negative b. That will give us a negative positive 3 or a negative 3 plus minus the square root of 3 squared minus 4 times 1 times negative 2 all over 2 times 1. Now I also want to point out, and this is a common place where students make mistakes, is that our formula has a negative, so that's a negative 4, and if either our a or c value is a negative, as it is in this case, you're going to end up with a positive here under our radical sign. That's important. A lot of students, if they make mistakes, will make a mistake here. Just be mindful of that when you're multiplying the back end of the part under the radical sign. So that gives us negative 3 plus minus the square root of 9 plus 8 all over 2. The next line is to simplify what's under the radical sign. That gives us 17. So our two solutions are x equals negative 3 plus root 17 all over 2 and negative 3 minus root 17 all over 2. Now there's no need to actually calculate what I would call the rounded value for these questions. If the question doesn't say give your answer in decimal form, you're welcome to leave it in this more exact form, because when you do root 17, that's going to be a long decimal number. Any sort of calculation that we do that then results in the rounding of root 17 will be less exact than leaving it in this form. So I would recommend that unless the question says it, you just leave it exactly like this. In part B, I'm going to actually work through one where we do round to one decimal place, just so you can get a little practice with the calculations. So as I said in the first example, here's our quadratic, negative 3w squared minus 7w equals negative 2. Now this is not in a form we can use yet because all of our terms are not on the same side of the equation. So to do that, I'm going to transpose negative 2 over to this side of the equation by adding 2 to both sides. And we end up with negative 3w squared minus 7w plus 2 equals 0. And now this is a quadratic equation in standard form, or similar to standard form. And my a value will be the coefficient in front of the squared term, that's negative 3. My b value will be the coefficient in front of the linear term, the one with just one w, and that's negative 7. And the c is there's our 7, and our c is our constant value at 2. Our first step is to rewrite, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The next step is substitution. Now you'll notice this time I'm substituting negative 7 in here, plus or minus the square root of negative 7 squared minus 4 times negative 3 times 2 all over 2 times negative 3. Now again, as in the first example, we have those two negatives hanging out here. That means we're going to have a plus under our radical sign, just something to be mindful of. So I'm going to simplify this first term. This negative 7 is going to be a 7 plus or minus the square root of 49. I also want to point out that the entirety of negative 7 is being squared, not just the 7 part, which means that we'll have 49 instead of a negative 49, and that is going to be plus 24 all over negative 6. So I'm going to simplify this just a little bit more under the radical sign, plus minus the square root of, that's 73 all over negative 6. So at this point, with that plus minus, and knowing that we're going to calculate it to one decimal place, I'm going to again consider two different scenarios. The first, where 7 is added to root 73 before being divided by negative 6, and the second scenario, where 7 is going to be subtracted from root 73 before dividing by negative 6. So we have two different scenarios here. I'm going to bust out the calculator now, and I want to point out that if you just type in 7 plus root 73 divided by negative 6, you will not get the right answer. The reason is, as I said above, we need to complete the numerator before dividing by negative 6. So when I type this into my calculator, I'm going to be typing in 7 plus root 73 and hit equals. And then I'm going to divide by negative 6. And that's going to give me x equals approximately negative 2.6. Let's work to our second example. Our second example, same thing. I want to finish my numerator before dividing by negative 6. So I'll type this into my calculator. I have 7 minus root 73 equals, and then divided by negative 6. And that will give me 0.3. So again, I'm finishing the numerator before dividing by my denominator. I can do that either by bracketing it, as I've shown you here in the examples, or, and I was using just my iPhone's calculator, you can hit a hard equals when you're done this calculation before dividing by negative 6. Either way will work. So those are our two answers. Now example C, we usually do in class as a way of illustrating that what the classes in 11U are doing are a little bit more complex, but not a new concept from the ones that we tackle in the 11UC class. I'm going to suggest that you just skip this just for ease. This isn't really the level of difficulty you can expect on any of our assessments, but it's just meant to illustrate that the differences between the 11U class and the 11UC class are those of complexity, not concepts. The concepts are going to be exactly the same. So the homework is at the bottom. Practice using the quadratic formula, especially for those of you who are new to it, having come from the grade 10 applied course. Work through the homework. If you have any questions, feel free to email me. Otherwise, good luck and we'll talk soon.